Okay, so please turn to where we left off last time, which is, okay, page 77. Okay, so let's go over question I, okay? So this is similar to the homework. We'll just start this one off to do a warm-up, right? So we'll start by substitution, right? Because you see there's a number 3 beside the x. So I'll let you try this now, okay? So we'll let 3x be a, right? And I'll let you carry out by yourself right now. So after isolate the tangent, the other side will be 1 over root 3, right? After that, you follow the PGG, right? So please raise your hand once you have the general solution for A. Okay, Cindy?
Hi.
Hi, yeah. Where are you now?
I'm writing down the general.
Okay, so can you tell me which quadrants are the angles first?
Oh, 1 and 3.
Yep, very good. And Tiana, what's the reference angle for this one?
Pi over 6.
Yep, over 6. Okay, so opposite, adjacent. So please raise your hand if you finish writing the general for A. And Samantha, do you have the 2 principal angles?
Pi over 6 and 7 pi over 6.
Yeah, very good. So Cindy, how many general solutions do you need?
Um, 2.
Why? Which 2?
Um,
Yeah, which two?
Pi over 6 plus 2 pi n.
Okay, and the other one?
7 pi over 6 plus 2 pi n.
Yeah, okay. Yeah, it's not wrong, okay, but you always need to ask yourself if there's a way we can simplify, right? Make it less general instead of two of them. Do you remember when we can, like how to tell when we can simplify the general solutions? Do you remember?
Not really.
Okay, because you didn't do the homework. Okay, you got to hand in the homework.
I have my physics final like today and tomorrow, so
Oh, okay. So last time we said that we can simplify it if the terminal arm, they make straight lines. Okay, so for example, like this question that you see here, right? The left side, you have straight lines, right? The upper line and the lower line. Then I can just add a pi, right? If you look at the solution, you have pi over 2, and then you can add a pi to get the 3 pi over 2. Cindy, do you get it?
yeah.
Yeah, okay, so together I can just write pi over 2 plus pi n instead of 2 pi n, right? Then that will cover both arms. So for over here, do you have straight lines for terminal arms?
Yes.
Yeah, okay, so we can simplify it, right? So I can start with what?
Pi over 6 plus 2 pi n.
Pi over 6 will give you this one, right?
Yeah.
And I can get to the other side just by adding how much?
Pi.
So I can just add pi n.
Yeah.
Understand?
Yeah.
Okay, so I don't need to do the 7 pi over 6 anymore because it's included in the pi n. Make sense?
Yeah.
Yeah, okay. And what else is missing at the back?
Still me?
Yeah, yeah, still you.
Oh, NEI.
NEI, yes. Okay. All right, how do we get the second general solution for x now? Tiana?
Divide by 3.
Yeah, so what would you get?
Pi over 18 plus 2 pi, plus pi over n, no, plus pi n over 3.
Yeah, yeah, very good. Okay, you just take whatever you got in the second G and divide by 3. And then you have NEI. All right, and then after that, we are looking for angles in the domain. So now you look at the final answer, right? And then you list out all the answer that fits inside by using the general solution, right? You start with n equal to 0, right? N equal to 1, 2, 3, 4, until it no longer fits inside 2 pi, okay? So when you finish writing all the solutions, please raise your hand. Or if you have trouble listing, okay? If you don't know how to find all the answers, okay, let me know. Then I can maybe go over the first few ones with you together, okay? Okay, Eric, how many solutions are there in total?
I got 5.
5 of them, okay. How about Ray? How many do you have? Ray? Ray, are you there? Is your mic working? How many answers do you have, Ray? Okay, Cindy, how do you get the first answer? First two answers. Have you got the first two?
No, why is it always me?
No, it's not always you. I'm asking everyone. Right? And then, well, if I don't ask you, I won't know that you don't know, right? So that's another way to find out if you know it. So to get the first one, right, you start with, you look at the general solutions, all right? The power 18 plus pi n over 3, okay? Yeah, Cindy?
Yeah.
Okay, and then you start by subbing in 0 into n. So n start with 0. So what do you get?
Pi over 8.
Pi over
18.
18, okay? And then to get the next one, you put n equal to 1, right? Start from 0 and then 1 and then 2 and so on, okay? Until the result is bigger than 2 pi.
Oh.
Okay, so when n equal to 1, you try one more time, okay? N equals to 1, what do you get?
Oh, 6 pi over 18.
But you need to add the power 18 at the front.
Oh, 7 pi over 18.
Yeah, okay, so that will be 7 pi over 18. Is that bigger than 2 pi?
No.
No, right? So you will continue, right? With n equal to 2 and then continue until it's bigger, right? If it's bigger than 2 pi, that means you need to make it bigger than 36 pi on the top, right? 2 pi is like 36 pi over 18. So you have to keep on going until it's no longer smaller than 36 pi over 18. Okay, Tiana, can you tell me the third one?
19 pi over 18.
19 pi is the next one. I think kind of too big. The third one. When n equal to 2.
Oh,
Right, first one is n equals 0, right? N equal to 1. What about
13 pi over 18.
Yeah, 13 pi over 18. Okay, Elaine, how about fourth one? You're
19
back.
pi over 18.
Say that again.
19 pi over 18.
Yeah, 19 pi over 18. Okay, I thought your mic is not working. Okay, Eric, can we fit more?
You can, yeah.
Yeah.
31 pi over 18.
31 is the next one. The one Ray gave us is n equal to 3, right? What about n equal to 4?
Oh, 25 pi over 18.
Yeah, 25 pi over 18.
Forgot that one.
Okay.
So there's,
Yeah. And then, Cindy, do you think we can fit another one there?
Yes.
And what would it be?
31.
31 pi over 18. Yeah?
Yeah.
Okay. Now, if you try to fit another one, right? If I want to do one more, what will be the next one? Samantha, what will be the next one then? After 31 pi over 18. When n equals to 6, what would it be? Are you calculating? Hello, Samantha? Are you there? Okay, how about you, Cindy? What will be the next one then?
Wait, what was the question again?
If I want to do one more, right? You gave us 31 pi, right?
Oh yeah.
What will be the next one then?
37 pi.
And then that one will be too big, right?
Yeah.
Yeah, okay, so that one we will throw out. So if you want to do this faster, instead of subbing 1, 2, 3, 4, 5, one by one, right? You can look for pattern, right? Once you get the first two, you can see that it's getting bigger by 6 on the numerator, right? And then each time you just keep on adding 6, right? Because it's using the same general solution, so the pattern should continue. So this way you can add faster instead of adding, instead of subbing in the end every time, right? Add a 6 will become 7, add another 6, right? 13, and then 19, 25, 31, right? So it's faster this way. If there are two general solutions, then you just do the same thing for the other one. Get the first two, and then keep on adding with the pattern, okay? Same gap, right? So this one, we should have total of 6 answers, all right? So depending on the domain, right? If I make the domain bigger, instead of 2 pi, if I say domain is 0 to 5 pi, then of course you get more answers, all right? So up to here, right, all of them needs you to find x, all right? So, but then question 40, sometimes the question doesn't need you to find answers. It's just asking how many solutions. So this kind of question is testing whether you understand the concept behind it, right? Otherwise, you can still answer this by solving everything out, but it will take much longer, okay? So let's see if there's a faster way to find out how many solutions there are. Okay, I'll let you try this first. Okay, we want to find out how many there are. For example, like this one, question I has 6. So think about if there is a way I can find out number of solutions without actually solve the whole thing, right? This one has 6. Look for pattern, okay? For example, this one, question G, right? This one has 2 sine 2x equal 1, right? Look at the question, right? And then at the end, you get 4 answers, okay? And then question H, you have total of, because you have 2 parts, right? For question H, you have the cosine A and also the cosine A plus 1, right? You have two questions. Cosine A equal to 0, cosine A equal to -1. And then one of them gave you 4, the other one gives you 2 answers. Okay, so look at these examples that we've done so far. See if there's a way I can figure out the whole thing, like how many solutions without solving every step. Okay, so write out the number of solutions. So total, there are how many solutions? Okay, you can make a guess, educated guess, right? or you can solve a little bit, right? Go a few steps and see if you can predict, right? So raise your hand if you figure out how many solutions there are. Okay, has anyone figured out how many solutions there are? Eric, what do you think?
I don't know.
Well, suppose you want to solve it. What will be your first step?
Change 3x, or let 3x equals a,
Yeah, and then?
and 2x equals b.
Sure, yeah, okay. So that we can do a few steps, right? 3x equal a, and then 2x equal to b, like that?
Yeah.
Yeah, okay. So what's after that then? What would you do next?
Do sine a equals 2 and cosine b equals -1.
Yeah, so you will solve each one separately, right? So you
Yeah.
look at each question equals to 2 and cosine b equal to -1. Okay, what about array? Have you got to here? Did you do something similar?
I don't know. I just put that there are 10 solutions.
Oh, you have 10 solutions at the end. How did you come up with that number?
I don't know how to explain it. I just did.
What did you do then?
I don't know. I just looked at the page and I was like, oh, there's 10 solutions.
Okay, that's interesting. I wonder how the 10, how you got the 10 though, all right? Let's just carry on from here then, okay? So suppose you're solving, okay? Let's see if we can somehow do a few steps, right? And then not solving the whole thing and then sort of predict, okay? So what would you do next after what Eric did here? What will be the next step? We have isolate each one, right? What do you do next? Tiana, what do you think? What's after this step?
Find the angle.
Yeah, find the angle. Right, we gotta follow the PGG, right? So let's start from the left side. How do we find the angle for the left side?
You draw the angle.
Draw the angle, okay? Can you tell me where to draw?
1 and 2.
1 and 2. And then what do you put on there?
2 is opposite and 1 is hypotenuse.
So like this,
Yeah.
okay? And then what did you notice? What do you notice now?
Doesn't look right.
Because
It's 2 I mean, it's like bigger than 1.
Yeah, hypotenuse is too what? Too big or too small?
Big.
Hypotenuse. What do you know about a hypotenuse? Is it too big or too small?
Big.
Too big? Hypotenuse too big? Hypotenuse is
Small.
1, right? Yeah, okay. Hypotenuse is 1, right? Smaller than 2. Hypotenuse always has to be the longest, right? So what does that tell you from the left side then?
Undefined.
Yeah, undefined. So on the left side, there's no PGG, right? There's no answer coming out from there, right? So let's look at the right side now. Cosine B, okay? Cindy, what do you think? What should we do next? Cindy? Cindy, are you there?
Oh, hi.
Hi, where'd you go?
Oh, no, I didn't. I don't think I heard you. I think it got cut off.
Okay, that's okay. So did you hear why it's no solution?
Yeah, because the hypotenuse is smaller.
Yeah, too short, right? Okay, what about the right side now? Cosine B equal to -1. How do we solve this one?
You draw the plane thing.
Yeah, and then where do we put the angle then?
Oh, quadrant 2 and 3.
Which one?
2 and 3.
Both of them? Like this?
Yeah.
Okay, but remember cosine -1. It's a special place.
It's the
Yeah,
line in the middle.
line in the middle, okay? Which side?
The left side.
Left side, very good, okay? So this one will give you an answer of, oh, this should be B. So what's the answer for B then? Still you, okay, Cindy? So what's the answer for B?
Pi.
Yeah, very good, okay? So get in pi. So this is the for the principal solution, okay? Now what about general solution for B, Ire?
Pi plus 2 pi n.
Yeah, pi plus 2 pi n. So we have one solution coming out within the 2 pi, right? 0 to 2 pi. And then with the general solution, you need to add 2 pi n. Now we need to get the general solution now for the x. What should we do to get the x? Eric?
Divide by 2.
Divide by 2, yeah? Okay, because b is 2x. So what's the answer then?
Pi over 2 plus pi n.
Pi n, okay? So we are kind of solving almost to the end, right? So what do you think? How many solutions do you think we'll have? We solve it to the end then? Let's list them out, okay? So what's the first answer? Ire? What's the first answer now? Ire?
Oh, pi over 2.
Okay. Kiana, second answer?
3 pi over 2.
Okay. Cindy, how about next one?
Too big.
Too big, okay, very good, all right? And the next one will be like adding a 2, right? 5 pi over 2 will be too big. So at the end, we only have 2 answers, okay? So Instead of 10, we have 2. So how can we figure this out, right? In the future, I don't want to solve all the way to the end. So if you look for pattern, on the left side, right? Of course, there's no solution, so I don't need to consider that, right? But if you look at the right side, if the domain is a regular one, okay, then the rule will work. If you look at the principal angle, okay, principal angle has one answer. Then your final answer will have 2 because the b is 2x. Okay, it will make it double, right? Because 2x makes it the first principal angle is smaller, right? Because you got to divide by 2, right? So kind of everything got shrunken, right? And then instead of adding pi n, you need to add, or instead of adding 2 pi n, you add only pi n, right? So all the answers are more cramped together, right? Are closer. So actually it will be double the original amount. Right, so that's one way you can predict, right? Let's see if that's true also for the previous question. For example, here, right, we have a 3, right? 3 is the answer there. And then over here for the principal, we have 2. So 2 times 3 is 6. So total here, final answer will be 6. Right, sometimes if you right, don't need to find the real answers, right? You just want to find out how many. This is how you can check. But this rule only work if you have a regular domain, okay, 0 to 2 pi. If they change the domain a little bit, it might be risky, okay? Because sometimes you might get more than that's there, depending on the domain. But if it's a regular one, right, 0 to 2 pi, you can apply this rule, right? We can also do check this one. Question G, right? The 2 is the number in front, so we know it should be double, right? So take a look. We have answer here, right? Principal answer has 2 of them. So 2 times 2, right? That gives you a total answer of 4. Okay, makes sense? So that's another way to do the question. But if you're unsure, right? Or if they use something that's a different domain, then you carry out the whole solutions. Okay, you can still find it. Right, now the last part for solving equation is to use identity. So initially I asked you to review, right? And also last week I asked you to memorize identity. So here is, we are going to apply them, okay, to help us solve it. So like if you look at question K, we know that we need to use identity if you see more than one thing, right? Because all the other question, right, you just have secant, right, or only tangent, right? Sometimes you see sine and cosine, like question D. But then that one I can factor, right, and make it into the left side sine, right side cosine. So this is still fine, right? No problem, all right? So if you have something like this, like question K, I couldn't factor anything out and separate secant and cotangent, right? Then you think about identity, okay? So you can take a look at your identity sheet now, right? Page 1, or if you have it in your head, right? Think about which identity we could possibly apply here. Okay, if you have any thing you want to try or any idea, can you let me know? Which identity do you think we can use it? So our goal is try to make it just one kind, right? Either make everything secant or everything just tangent. Okay, so it's easier to work with. Okay, so take a look at your list of formulas. Which identity has secant and tangent, right? Take a look. Have you found it? Cindy, which one? Do you see any identity that has secant and tangent?
The triangle on the bottom left.
Okay, what does that say?
Wait, what?
Which identity is that?
The tangent and the secant one?
Yeah, and then which group of identity is it? We have the quotient, right?
Tan squared a plus 1 equals secant squared a.
Yeah, okay, so that's belong to the square identity, right? Okay, so that one, let's write it down first, okay? Tangent square plus 1 equal to secant square. Okay, so by using this, right, we could replace the secant square with tangent square plus 1. So that makes the whole question just in terms of tangent. And then we can go from there, okay? So we are going to use the identity here. So we substitute, right? 2 secant, so instead of secant square, we have tangent square plus 1 plus tangent equals 3. Okay, and then we'll simplify this. 2 tangent square x plus 2 plus tangent x equals to 3. Okay, so what do you think we should do now? We have made everything in terms of tangent, right? Then you think about your other methods now, okay? You have method 1, right? Can we do isolate, right? Method 2, factoring, right? Or should we be using substitution, right? Do we need to do substitution, right? Because we have used identity already. So what do you think we should do now? Ire?
Move 3 over.
Okay, so we make one side 0. So what will be on the left side then, Ire?
2 tangent x squared plus tangent x minus 1.
Yeah. Okay, so once we get here, then we can think about applying which method? Eric?
Can you do a factor?
Yeah, so we'll see if it's factorable, right? Even if it's not factorable, you can still use the quadratic formula, right? Because it looks like a quadratic equation, right? So let's try, right? See if it's factorable. Once you finish factoring, please raise your hand. So array is factorable?
I think.
Yeah, okay. So this one, you don't need to use the substitution, okay? There's no number before the x, right? So you just go ahead, solve for the x, right? You don't need to do the PGG, right? Okay, Cindy, any question about how to factor here?
What? No.
Okay, so when you finish factor, please raise your hand.
Oh,
Okay. So Tiana, what are the two factors?
2 tan x minus 1 and tan x plus 1.
Okay, so let's see. Yeah, that looks works. Yeah. Okay, then from there we just solve each side. So tangent x can be either half, right? And then the other one is tangent x is -1. Right, so from here, I'll let you finish and then solve the answer in domain, okay? So if you finish the whole x, I think from the left side, you can get 2 answers, right? Right side also 2 answers. So total, you should get 4. Okay, we are looking for answers within 0 to 2 pi, okay? You don't need to do general solutions. But we could practice, okay? Angles in domain. Angles in domain. And the next one, we'll do general solutions. Okay, so also think about how many general solutions do we need, right? If we have 4 answers here, do we really need 4 general solutions? Okay, if you have found the 4 answers, please raise your hand. Okay, for the left side, it will be quadrant 1 and 3, right? Right side, it will be quadrant negative, quadrant 2 and 4. Does anyone have trouble finding the 4 answers? Okay, Cindy, do you know how to find the answer for the left side?
I'm not sure if I use radian or degree for it.
Okay. Do you know where to check if it's radian or degree? Look at the domain. What do you see in the domain?
0 is less than or equal to x. Less
0
than,
to 2 pi, right?
yeah,
Yeah, is that radian or degree?
radian.
Yeah, so we need to be in radian.
Uh,
Okay, so if they say 0 to 360 degree, then you know you need to be in degree. All right, so once you get the answer for the left side, okay, Cindy, when you get the answer for left side, let me know, all right? And Eric, what's your answer from the right side?
Like the
From
reference
the,
angle?
huh?
Do you mean the reference angle or the
No, the answer, angles in domain.
3 pi over 4 and 7 pi over 4?
Yeah, okay, because I think by now, right, you guys should know how to get the reference, right? And then get the sides. So we're just checking the final answer. Okay, and then general solution for the right side. Tiana, do you have it?
Is it 3 pi over 4 plus n, pi n?
By n, yeah, very good. Okay, so right side, they makes a straight line. So you just need one general solution. Okay, Cindy, have you found the answer for left side now? Can you hear me, Cindy?
No, I got the angle.
Yeah, you got the angle for the left? Okay, so what's your answer?
0.46.
46. Okay, and next one?
Wait. What?
You have two answers, right? For the left side.
Oh, do I times it by something? Oh, do I times it by pi?
No, take a look. Look at the picture, okay? Don't try to memorize. Your 0.46, is it for this one?
Yeah.
Yeah, so you want to get to the next one, right? So how far away? What?
Do I add pi?
Yeah, so you need to add 180 degree, but in this case, you add pi, right? We're in radian.
3.6.
3.60.
Yeah.
Yeah, okay. All right, let's check. Ray, do you have the same thing for the first two answers?
Yeah.
Okay. All right, so what's the general solution then? Cindy.
Um, 0.46 plus pi n.
Yes, okay, so you got it this time, right? They make a straight line, so I don't need to do 2 pi n, okay? Adding a pi n will include both, right? So we use this question to also review how to get general solution too. So to solve this, right, once again, you need to check, right, if we can make everything into one kind, right, and then solve for it. Okay, so let's see if we miss anything here. Okay, seems all right. Okay, so let's look at next question. So this is how it has to be done, right? Just our goal is try to make everything one kind. But sometimes we could also, right, even though we have two kinds, right? We have an example there, question D. Even though there's sine and cosine, sometimes we could separate, right? If we are able to factor, make two kinds they separate, then it's also fine, right? Then it's solvable. All right, so let's look at question L now. Here we have secant, we have sine as well, right? Two kinds. So think about which identity we could use, right? What's the way we could make it solvable? Okay, let me know if you have any idea, right? Or any suggestion you want to try. Okay, take a look at the question. Think about what's special about this one. Okay, does anybody want to say like what to do here? How to start? Eric? What do you think? Anything you want to try?
I don't know.
Oh, what do you see special for this one?
It's 2 sine x.
Yeah, two of them, right? You have a sine x on the left side, sine x on the right side. So what do you think we can do with that?
Subtract.
Subtract. What do you mean subtract?
Or no.
You have something the same on both sides. So what can we do?
Divide.
Anyone? Yeah. What did you say?
Divide.
Divide. What do you want to divide by?
Sine x.
Want to divide by sine x? Okay, let's write that down. Secant x sine x. 2 sine x. And then we're gonna divide both sides by sine x. Okay, so what would that become then after that, Cindy?
Secant x equals 2.
Secant x equal to 2. Okay, so seems like sine x canceled out, right? So that makes the whole question just secant x. And then you solve for x from there. That would be nice. Right? Ray, what do you think? Did you try the same way?
Yeah.
Did you also cancel out the sine x?
Yeah.
Yeah, okay. And then of course we can solve from there and get the answer for that. Now I would like you to think about a question on the side, okay? Keep that on the left, okay? Don't erase it. So let's say if we have, let's say 2x squared equal x. Kind of similar to what we have on the left, right? We have something the same on both sides. Okay, so if I do the same thing, at both sides divided by x, then what would you get on the next step? Tiana?
Two x equals to 1.
Yeah, then I will get 2x equal to 1, 2x equal to 1, and then we solve for x equal to 1/2. Right? So that will be the way if we do it this way, right? If we just get rid of x on both sides. Now, is there another way to do the same problem? 2x squared equal to x. Can I solve it a little bit differently without dividing the x away? What other ways are there? What can we do? Anyone? You have seen this before, okay? This is a quadratic, sort of like quadratic, right? You have a square there. How do you solve a quadratic equation? Instead of divide both sides by x, what other approaches we can do instead? Cindy, what do you think?
Minus x.
Okay, minus x. So what would it become then?
2x squared minus x plus 0.
You mean equals to 0?
Oh, yeah.
Yeah, okay. So then the other side, you move everything to one side. And then what can we do after that, Eric?
Take out x.
Yeah, then we can do factoring, right? So x will be taken out. What's left then, Eric?
2x minus 1.
All right, and then we solve each one, right? We make each bracket equals to 0. X equal to 0, 2x minus 1 equal to 0. So that can give us x equal to 0 or a half. So you see the way that without canceling the x, it will give you two answers, right? But if you cancel the x, you will lose an answer, right? So you have to be careful. The reason why you lost an answer is you got rid of a variable, right? So you sort of changed the question, right? This original question has a square, but you got rid of one of them, okay? So if there is a variable, remember you cannot cancel it out, right? So that's why over here at the top, I said, watch out, right? Watch out. You might lose an answer, lost answers. So you will lose answers when, okay, you can write it on the top, when divide by variables, or when cancel out the variables, okay? So make sure you don't do that, okay? So this is a good try here, right? Because this tells us what happens when you divide by a variable. So just like on the left side, sine x is a variable, right? If you divide by that, you kind of change the equation and then pretend the question is only secant x, and you ignore the sine x completely, right? Then you'll lose answer coming out from the sine. All right, so instead of dividing, okay, so now we know that it's not good to divide by variable, right? So what should be the correct step then? What should we do to begin? Eric, what do you think now?
Subtract 2 sine x from 1.
Okay, so we'll move everything to the left side now. Secant x, sine x, minus 2 sine x equal to 0. Okay, even though we know both sides have the same, but we want to move it to the same side and then factor it out. Okay, so that way we don't lose any answer. Okay, so we can take out sine x. Left over will be secant x minus 2 equal to 0. And from there, right, you solve each one. Okay, so I'll let you complete the rest of the steps. And please raise your hand when you finish the rest. Okay, so you find the answer in domain. Okay, and then find the general. Okay, so once you finish these two, please raise your hand. Okay, from the left side, I'll write a couple steps. Left side will be sine x equal to 0. Right side is secant x equal to 2. And draw the picture for each one. Please raise your hand if you finished. Okay, Cindy, do you have the answer for the left side?
0 and pi.
0 and pi, very good. How about general?
Like 0 plus 2 pi n.
0 plus 2 pi n. Do they make a straight line?
Oh, pi n.
Yeah, okay. So just 0 plus pi n, you can just write pi n, right? 0 is invisible, right? So that will include both lines, right? The right side and the left side. Okay, now secant equal to 2, right? The answer from the right side. Ray, what do you have?
I got pi over 3 and 5 pi over no wait. And 5 pi over 3.
5 pi over 3. And what about general?
Pi over 3 plus 2 pi and 5 pi over 3 plus 2 pi n.
Okay, so you have 2 of them from the right side. Okay. Tiana, what about you? What do you think? Is the right side the same?
Yeah.
Yeah, okay. Also pi over 3. Okay. So let's quickly check. Okay, secant is same location as cosine, right? So positive will be here. And this one is hypotenuse over adjacent, right? Hypotenuse over adjacent, though that will give us reference as pi over 3. Yeah, that looks correct. Okay, then we get 2 answers. Okay, one more question, okay, before we go for break. So this one is having 3 of them, right? You have cosine, you have tangent, you have secant. And there's no square here, right? Because like square, right? For the square, I could use the square identity and then replace it, right, with other ones. But this one doesn't have square. So maybe you can throw out the square identity. Unless other things doesn't work, then we can go back and think about square. And then this one, if we try to do the same thing as L, right? Move everything to one side. It still won't work, right? Because you have secant, you have tangent, and cosine. You don't have anything the same that you could factor out, right? So still back to the list of identity. So think about which identity can help us change it, right? So it doesn't, we don't have to deal with 3 things. Okay, sometimes it takes more than 1 steps. So let me know, right? If you want to try something, we can go over it together. We are going to go over it, but I need your help, right? Give me some ideas. And then we can discuss whether it works or why it doesn't work, right? So let me know, what do you want to try? Take a look at the identities. So anything you want to change? Irae, what do you think? Anything you want to apply here?
I don't know.
Choose one. Think of an identity. It's not square, right? There's no square here. So what other identities are there, Irae?
Nothing.
Nothing. We have different groups, right? What other groups are there? Cindy?
I don't know.
Well, look at, no, you have to know, right? Because it's on the list, okay? My question is, what other groups are there? And then let's throw away the groups that doesn't work, right? So we have the square identity. We don't have square here, right? So square doesn't work. What other groups are there?
Double angle.
Double angle, okay? Do we have any double angle here?
No.
No, right? So those are out, right? So throw those away. Square is out. Double angles are out, right? There's no double angle. Double angle is if you have a 2x, right, in there, then that's called double angle. There's no double angle. Okay, what other groups are there then?
Quotient.
Quotient, okay, what's in the quotient?
Sine A over cos A equals tan A.
Okay, do we have something like that here?
No.
Do we have tangent?
Yeah.
Yeah, then we can use it, right? Do we have cosine?
Yeah.
Yeah, we also have cosine, right? So something is kind of connecting, right? Sine, cosine, tangent, even though we don't have sine, but at least we have tangent and cosine. So let's keep that in mind, right? What other identity are there? What other groups other than quotient? Anything that has secant.
Reciprocal.
Reciprocal, okay? Which one of the reciprocal?
Cosine x equals 1 over secant x.
Okay, which means secant x is what?
1 over cosine x.
Yeah, I can write it as cosine as well. Make sense, right? So we have, at least instead of having 3, maybe we can make it down to 2 variable, right? That's better than having 3 kinds. Cosine, tangent, secant, right? Too many. So at least we can bring the secant into a cosine, right? We can write 2 cosine x plus, okay, we'll leave the tangent there for now. Secant x, I can at least write it as 1 over cosine x. Right? And what do you want to do with the tangent then? Irae?
I still don't know.
Well, Cindy mentioned an identity we could use for tangent. Which one is that?
Sine divided by cosine.
Yeah, okay. So we can put it into sine over cosine. So at least now we just have 2, right? Just have to deal with sine and cosine. Okay, so what do you think we can do now? Let's make a note, right? For what happens. This one is using the quotient. right? This one is using reciprocal, right? That's how we get the new line, right? So this is why you need to try, right? Sometimes it's not very clear what to do when you see this on the homework, right? But you gotta try it out. At least we're making some progress, right? Making the question look easier. Okay, so what should we do next now? Anyone? We have something the same on both sides, right? We have over cosine, right? What should we do? Did we have something similar to this? Like we have something the same on both sides. Cindy?
You can do like 1 minus sine x over cos x.
And what about the 2 cosine?
I mean, you can move it over too.
Okay, so we can move everything over. Right? Think about what happened before, right? Remember the last question? When we have something the same on both sides, instead of getting rid of it, right? It's better to move them to the same side, right? And then see if we can factor, right? Or simplify from there. So you don't want to get rid of the same thing, right? You don't want to get rid of the cosine at the bottom. So I'm going to move everything to the left side instead, okay? So it'll be 2 cosine x plus sine x over cosine x minus 1 over cosine x equals 0. So the common mistake is to multiply both sides by cosine, right? Like this. If I multiply by cosine, it will cancel out the cosine. Then that will lead to losing answers. Okay, so you don't want to do that. You can move everything to one side. Okay. All right, now once you move everything to one side, and we have a couple fractions here, right? So we could combine the fractions, right? We already have 2 of them the same denominator. So let's make the third one, right? The 2 cosine also same denominator. You can write it as over 1 right now. And then combine the fraction together. Okay, so what will be the new numerator now? How do we get the numerator? Tiana? How can we find the numerator?
I'm not sure.
We are just adding fractions, right? So do you know how we get a common denominator?
Times by cosine x.
Yeah, so this is 1, right? 1 needs to times it by cosine x. So what do we do to the top?
2 cosine x squared.
Yeah, so we also need to times it by cosine x. Okay, the other 2, they are just the same, right? It already has a denominator, so we just copy it. So we have this. Okay, so right now what we have in front of you is a fraction equal to 0, right? Left side is a fraction, right side is a 0. How do we make a fraction equal to 0? Which part needs to be 0? Eric?
Numerator.
Yeah, numerator has to be 0, right? What about denominator? Can denominator be 0? Cindy?
No.
No, right? So denominator can never be 0. That's a restrictions. Okay? So if you have a fraction, you want to make it equal to 0, you just need to make sure numerator equals to 0. So now the question has been broken down into the top equal to 0, and then the denominator cannot be 0. 2 parts. Okay, make sense? Okay, let's recap it a little bit, right? We start with cosine, tangent, and secant. And by applying the 2 rules that you chose, right? Quotient, reciprocal, because it cannot be squared, cannot be double, right? And cannot be sum and difference. There's no sum and difference here, right? So it has to be like quotient, right? Either quotient, reciprocals, you choose from there. And then because you have something the same on both sides, so you decided to move to one side, right? And then you have couple fractions, we combine them together. And from here, we learned that something new here, right? If you have a fraction equal to 0, you just split it into 2 parts and discuss each part separately. Okay, so once you get to the left side, right? Look at the left side now. You only have cosine and sine. And you have a cosine square. Does that give you any hint what to do next? Okay, if you know what to do, can you raise your hand for the left side? What should we do if there is a cosine square on the left side? What should we do? Anyone know? Cindy, what do you think?
No, I don't know. I read the question wrong.
Okay. What right now, right? The left side has 2 of them, kind of like this one. This one has 2 of them. Question K, right? Has a secant square, has a tangent. Right? Left side we have a cosine square, has a sine. Right? Kind of similar. Come on, you can do it. Anyone else know? Can you raise your hand if you know what to do? Of course, I can keep on talking, showing every step. Then that way you don't have the chance to think, right? And then when the question change, you'll be lost, right? So I'm giving you a chance to trigger your thinking, right? What have we done before? Can we do something similar here?
You can change 2 cosine squared x minus 1 into cosine 2x.
Can you say that one more time? Which identity are you thinking of?
Can you use double angle?
Okay, which one?
The second one.
Okay, so you said 2 cosine square x minus 1,
Yeah,
and then becomes what?
cosine 2x.
Cosine 2x. So okay, I see. So you're thinking about this one and the minus 1 at the back, is it?
Yeah.
Yeah, okay, so that will replace it into cosine 2x. However, this one has a double angle, right? 2x. But then the sum x doesn't have a double angle, then we will have a problem. It's still different.
Oh, okay.
Okay, but you're close, pretty good. Okay, you notice the double angle one. But we can do a little bit change, right? Or instead of replacing it as cosine 2x, what other option to replace it as? Look at your identity. 2 cosine square x minus 1 can also equal to what? Anyone can try, okay? Look at the identity. Eric already gave us a very good hint here now. 2 cosine squared minus 1. Instead of making it equal to cosine 2x, what can I make it equal to instead? So it's helpful. Should we pull out a square identity? Not square identity, double angle. Take a look. The middle one, right? 2 cosine squared x minus 1. This one not only equal to cosine 2a, but also equal to the cosine squared minus sine squared, right? But also equal to 1 minus 2 sine squared, right? Which one should I replace, right? Because they all equal each other. All these 4 green circles, they all equal each other. Which one will be helpful to replace? Anybody? Let's write it on the side. Cosine 2x, cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. These 4, they all equal each other. Which one should we use? So it's helpful to the question. Elaine, what do you think?
1 minus 2 sine x squared.
And why would you choose that one?
Because it has sine.
Yes, very good. Right? So take a look, right? You have, if I replace the red part, the underlined red part with 1 minus sine 2 sine squared, right? Then the whole question can become in terms of sine. Okay, so I'm going to choose that one. 1 minus 2 sine squared x. Right? So that's another way to use double angles, right? So you don't always have to make it equal to cosine double, right? Or sine double, right? You can choose. Only for cosine double, you have more than one choices. Okay? So if I substitute the red part with the 1 minus, right? 1 minus 2 sine square x, right? And then you just add a sine x equal to 0. Okay? And then we can move it around. I could put them in different order. So now it looks like a quadratic. So hopefully I can factor this again. Okay, so can you please factor this? When you finish factoring, can you please raise your hand? So that's why I say the identity, right? It's better that you memorize it. Otherwise, when you see it, you don't feel it's familiar to you, right? Everything is a stranger, right? But if you're very familiar with your identity, you see 2 cosine squared minus 1, you can connect, right? Connect to the formula. Okay, so please raise your hand if you have finished factoring. It should be factorable. And once you've factored it, okay, you can go on, solve each one. And then find the x. Okay, Tiana, have you factored yet?
Yeah.
Okay, what do you have?
-2 sine x minus 1 and sine x minus 1.
Sine x minus 1. Thank you. Okay, so let's see. -1 plus 2. Yeah, okay, that looks good. Okay, so you would have one side that will be -½ the other one is equal to 1. Okay, so each one you need to draw it out. Okay, so please raise your hand if you find all the x. For the left side should be quadrant 3 and 4, right? Sine negative. For the right side, this is a special place, right? Sine x equal to 1. So I hope you remember that, okay? Sine x equal to 1. So looks like we'll have 3 answers here, right? Please raise your hand if you got them all. Answers in domain. Our domain is a regular one, okay? Domain is just 0 to 2 pi. Okay, Eric, what's the answer for the left side?
7 pi over 6.
7 pi over 6 and
11 pi over 6.
11 pi over 6, okay? Ire, how about you? Left side.
Same.
Same, all right. Now right side. Right side, Tiana, do you have it?
Pi over 2.
Pi over 2, yeah. Okay. So that's all the answer within 0 to 2 pi, right? Is there anything else we forgot? Is that it? Did we forget to do anything? Should we just hand in the answer now? I bet Ire will say yes, right? Ire, is there anything else?
I don't know.
Anything that we mentioned before, but we haven't checked yet, right? Anything that we didn't look at? Eric, what do you think?
The cosine x.
What about it?
Or
Cosine x what?
can't equal 0.
Cannot equal to 0. Yeah, you cannot ignore that, right? Because it's part of the question, right? That's why we split it, right? It should be there for a reason. because everything that we found is only to make the numerator equal to 0, right? We look at the numerator. Now we need to look at the denominator as well, right? Cosine x cannot equal to 0. Remember, it will be 0 for cosine, it will be up here and down here, right? 2 places. So that's telling us that x cannot be what? Cindy? What value for x it can equal? Huh?
It can't equal 0.
Huh? Where did you go? You were chatting?
No, because I have to leave soon.
Oh, you have to go at 6:30?
Yeah.
Yeah, okay. Just answer this one, right? Can you tell me what's the angle for the red line?
Pi over 2.
Yeah, and the other one?
3 pi over 2.
Yeah, so x cannot equal to pi over 2 and 3 pi over 2. Okay, and then that will reject the answer that you get here. Okay, so your final answer that you should keep is only 7 pi over 6 and 11 pi over 6. Okay, so this answer that we reject, we call that the extra answers. So be careful when you see something like this. Okay, so Cindy, I'll see you next class. Okay, make sure you check the video. We're still gonna cover more things. Okay, after the break.
Okay.
Okay.
Bye.
Yeah. Bye-bye. Okay, so let's have a break now. Okay, for 15 minutes. So I see you guys at 6:50. Okay.